Hello and welcome to the physics topic Forces 2, Lesson 4, Pressure. We are going to look at the effects of pressure and the link between area, force and pressure. So we will also take a little look at pressure in liquids as well as atmospheric pressure. Now, you need to know the equation for pressure. So pressure, very simply, is calculated by knowing the force and dividing that by the area that force is acting on. Now, force is measured in newtons, area is measured in meters squared, so pressure is then measured in newtons per metre squared or also pascals. That's what the PA there is representing. This formula triangle can also be rearranged so that if you're given some information, like for example, if you're given the pressure and the area and you need to calculate the force, or if you're given the force and the pressure, you can calculate the area that force is acting on. So you can use the formula triangle to calculate the area force is acting on. You can do this by saying the area is equal to the force divided by the pressure. You can also use the formula triangle to calculate the force with which an object presses on over a certain area, and that is the force equal to the pressure multiplied by the area. And we can show you a couple of examples of these. So a pile of books weighs 15 newtons and the base of the book, so the bottom book of the pile, has an area of 0.6 metres squared, and you are to calculate the pressure exerted by the pile of books. So you work out that you need pressure equals force divided by area, and then you substitute in the numbers that you've got. So the pressure is equal to 15 newtons, the weight of the books, divided by 0.6 metres squared for the area that the base of the book covers. And that gives you a pressure of 25 newton metres squared or 25 pascals. So need to have an understanding of pressure in liquids, how that happens. So the deeper the liquid, the pressure will increase the deeper you go in that liquid. And the reason that's happening is because of the weight of the water above you. So that's why divers can experience issues when they dive deep down, and particularly inexperienced divers aren't meant to go too far until you've done certain levels of training, because you've got additional weight on top of you, so the pressure is increasing the further you go. So you can apply that to the fact that if an object is placed in water, there's water pressure acting on it. So the force of the water will be greater than the force of the object, will be greater than the force pushing the object down into the water. So there you'll get up thrust, and as the example in this picture with the rubber duck, it enables the object to float. However, if the object's weight is more than the water pressure, like this picture with the boat is trying to represent, then the object will sink. The weight of that boat is more, particularly say, for example, if there'd been a leak and water had filled into that boat. So the weight of the boat filled with additional water will cause it to sink. And then finally, last bit you need to know about is atmospheric pressure. And this is relevant if you're having a change in distance from sea level. So the atmospheric pressure decreases as you increase your distance above sea level. So to put that into context, the higher up a mountain you walk, the lower the atmospheric pressure. And that can cause sickness with people as they are walking, as they're mountain walking or climbing mountains when they're not used to it, particularly much higher ones. Okay. So we've looked at pressure, we've looked at how to calculate pressure, we've also looked at pressure in liquids and atmospheric pressure.